Okay, the answers to Collecting Like Terms Lesson 1. Question number 1 is 3x add 7x. So I'm going to have a row of 3x's and a row of 7x's. And I can now look for any zero pairs, and there aren't any, and then sum to find positive 10x. So 3x add 7x is identical to 10x. Question 2. 10x add 4x. So I have 10x's in my first row. And then in my second row, 4x. I'm then going to look for any zero pairs, and there aren't any. And then I can sum to find a total of 14x. So 10x add 4x is identical to 14x. Question 3. Is slightly different because it's a subtraction. So I need to think carefully about the direction of my terms. So 9x subtract 3x. And this 9x here has a positive direction. And I'm going to think of this as adding negative 3x. So I need 9x's in my first row. And then negative 3x in my second row. I'm going to look for zero pairs, and there are 3. And so I'm now left with positive 6x. So 9x subtract 3x is identical to 6x. Question 4. Very similar, but now I'm changing variables so that I'm working with y's instead of x's. And I'm going to think of that as positive 14y add negative 3y. So I need 14y's in my top row. I'm now going to go off the screen for a moment. And then I need to add to that my second row, negative 3y. Look for zero pairs, and there are 3 of those. So those are 0. And then I can move across so that you can see the rest of them. And I have got there a total of 11y. And that, of course, is a positive 11y. So 14y subtract 3y is identical to 11y. Okay, question 5, sticking with the y variable. But this time my first term is negative. So question 5, negative 3y add positive 8y. So I'm going to think of that negative 3y add positive 8y. There's my negative 3y. And now positive 8y. So I'm now going to look for zero pairs again, and these are my zero pairs this time. So those are 0, and I'm left with summing the rest, which is positive 5y. So negative 3y add 8y is identical to 5y. Question 6 is different only because we're now looking at 3 terms, and this is, they're all positive direction. So it's positive x add positive 2x add positive 5x. So I'm going to need an x, a 2x, and 5x. And I can just sum those as they are, but it might be better for questions that are coming up later to think of this as grouping together my positive x's. And then I can see that when I sum those, I've got positive 8x. So x plus 2x plus 5x is identical to positive 8x. Right, question 7. Again, I'm moving back to the y variable, and this time I have got 4 terms to work with. And the question is 3y subtract 4y, add 7y, subtract y. And the way I'm going to think of these is as the direction of this term and this term. So I'm going to think of it as positive 3y, add negative 4y, add positive 7y, add negative y. So I'm going to need 3 y's in my first row, negative 4y in my second, 7y as my third row, and then negative y as my fourth. And the way I'm going to think of this is to collect together my positive y's, and then collect together my negative y's, and then look for my 0 pairs, and now I have 5, and then sum what's left. So I'm left with positive 5y. So 3y add 7y, subtract 4y, subtract y is positive 5y. When I was moving those counters around, I was using the commutative law so that I changed the calculation, the order of the calculation, so that it became this. But as we know from the commutative law, I can do that and it does not change the answer. So the answer is positive 5y. Okay, question 8. Moving back to the x variable, but this time I'm going to need some skills that I learnt when we were looking at negative numbers, because I've got positive 8x subtract negative 7x. So I'm going to have 8 x's and 7 negative x's. Now, I can't sum those as they are because this isn't a sum, it's a subtract, it's a difference. But I know that a subtract changes the sign. So that means I'm going to flip my counters, and this new calculation, alternative calculation, is positive 8x add positive 7x. So subtracting a negative is the same as adding a positive. Now I can look for any 0 pairs, and there aren't any, and then sum to get a total of 15x. That should be an identity sign. Question 9. Very similar, but this time with the y variable. Negative 12y subtract negative 5y. So I've got 12 negative y's. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 5 negative y's. A subtract changes the sign, so I'm going to flip. And then sum. So my alternative calculation is negative 12y add positive 5y. I can now look for my 0 pairs, and there are 5 of those. So that is all 0 there. And then sum what's left, and I've got a total of negative 7y. So negative 12y subtract negative 5y is identical to negative 7y. I could have answered each of these questions with a bar model instead. So if you've done that, that's fine, provided you've got the same answer. And you would have needed to partition your bars in order to create your zero pairs. Question 10, though, I'm going to need a bar model because I can't create half a counter. So the question was a half x add a half x. So I'm drawing two bars of a half x. I need to collect together my positive x's. And then sum. So I know that a half x add a half x makes a sum of x. So a half x plus a half x is identical to x.